Okay, so it's 2 o'clock. So deploying an IPv6 network, production IPv6 network in 30 minutes or less, or it's free. So we actually worked this out in advance with Betty. If you guys can't deploy an IPv6 network, you can get this portion of your registration fee back. It's like $5. You can go out front and ask for it. So I want to start by identifying the target audience. So there's a lot of people out there that are running IPv6 networks that have been doing it for years. There's a lot of expertise out there, a lot of experience, and there's a lot of people who are IPv6 zealots, people who have really been pushing this for quite a while. And there's also a bunch of people that haven't been. So this talk is specifically targeted to people that haven't done IPv6 yet for whatever reason. So, the concerns that I've heard are there's people that don't want to risk impact to their network by turning on v6. There's people that don't want to spend money on new hardware to do it. There's people that have software that they just haven't adapted to handle v6. There's a lot of general interest in letting other people hit all the bugs first and then do it themselves. There's people that say, well, there's no commercial driver. No one's paying me any money to do v6, so why do I care? There's people that are going to, they just haven't gotten around to it. And there's people that just don't like v6. Or in other words, this talk is for Cogent. Everyone point to Aaron Weintraub. Well, I bring that up because there was a thread on Nanog the other day where Cogent said they weren't going to do v6 because they just didn't want to. Well, that's Cogent's position. And the point being, Cogent has all the tools in place to do it already. They just haven't done it yet. And this is to explain to them how. I expect a copy of this on Dave. I expect a copy of this on Dave Schaefer's desk by Monday. The only known alternative to deploying IPv6.
So if it only takes 30 minutes, why is this 90-minute pop?
I don't know. Don't ask me. I didn't do scheduling. So what I want to talk about here is easy ways to deploy v6. Particularly for dual stack networks. I mean, there's people out there that are running tunneled implementations, that are running, dedicated 2600 somewhere to do their v6. And I consider that cheating. It doesn't really scale or work anyways and just creates problems and really reduces the quality of v6 implementation to the point where people don't want to use v6 because the network sucks so bad. So I want to talk about how to do it dual stack with a native v6 network with minimal hardware upgrades, or hopefully not at all, with minimum management software changes, with the least amount of pain possible, to make it scalable, make it easy to maintain, make it not a hassle to implement, and of course not to break v4 in the process. So, quick overview of IPv6. I'll leave the quote for you to read. But honestly, v6 isn't that hard. I mean, really what it comes down to, IPv4 had 4 groups of 8 bits separated by a decimal. Now you've got 8 groups of 16 bits by a colon, and now it's in hex. Probably just so you can implement the Dead Beef Cafe babe jokes. It confuses a lot of people, but it's not that difficult. And also, you can encode IPv4 addresses in IPv6, and they just convert to hex, and that comes into play later. And also, to ease the headaches of a big, long-looking number, if there's a big, long string of zeros, you can just replace it with a double colon. So you get an address that's not too hideously long. And if you can't do hex math, just use a calculator. IPv6 really is just like IPv4 with more bits, except that we're not supposed to use the last 64 bits. What's been suggested by the people that have done the IPv6 spec is that we reserve the last 64 bits for host addressing and just use the first 64 bits for routing so that you get automatic IP addressing. You plug your computer in, it's got an IP already. At the end of the day, that may actually not be a requirement because since IPv6 was written, they came out with this thing called DHCP. You might have heard of it. It kind of solves that problem. And for a lot of people, they have to run DHCP anyways for authentication, authorization, whatever the case may be. So the stateless autoconfig isn't really helping. And if you do use this, you probably don't want to use it on your router interfaces. The point being, it's not very easy to figure out what the far side might be numbered. And it also makes for a really long, nasty address that is just harder to keep track of. So, one of the things that I came up with to do a v6 rollout was the dual stack addressing trick. Really what it comes down to is, for most people, the biggest problem with rolling out IPv6 is a layer 8 problem. They have to go update their management software, they have to go update their IP allocation database, their DNS management system, whatever it may be, so that, how do you go provision a whatever block for your customer interface, for your router interface, how do you go set DNS? It doubles the work for a lot of people, and it requires a lot of software changes. So what I wanted to do was find a way that you didn't have to do that, where if you had an existing v4 network, you could roll it straight into v6 without all that headache, and have your DNS automatically set based on your v4, have automatic v6 addresses. So I just call it the IPv6 dual stack addressing trick. So let's say, for example, that you have this IPv6 block, so you have this 32. What I chose to do was just peel off a 96 to represent the current IPv4 space. You could do it some other way if you wanted to, but this happens to make it the shortest address, and it looks good in traceroute. So if you just pick the first thing that's 0-based, carve out that 96 and use that to represent your current v4 space, it just works. So when you convert your netmask, you just add 96 to it. So where you once had a /30, you now have a /126, and you can literally just type in the IPv4 address at the end there, and it'll take up 32 bits of that last space. And there's a lot of router code out there that'll just automatically convert this to hex for you, and you'll just get a nice address, and it just works. And then it's really easy to implement. You don't have to go implement additional software to do v6 allocations. You have a v4 address already, and then you just type in your v6 statement. So literally, you instantly get v6 deployed on every router, every circuit, every peer, every customer interface on your network with no work. It's really easy to copy DNS from your v4 zone, so you don't end up with, there's a lot of networks out there where you run a big v6 trace route and it comes out with no DNS because they don't have the time or energy to go maintain that. So it just solves all your problems. And you don't have to go modify your customer tools or anything like that because the v6 address is already there mapped from your v4. The disadvantage, obviously, is that it requires v4 to do this. So it's pretty much for networks that are dual stack, which is everyone. Honestly, you just can't do a v6 only network anyways. There's so many missing pieces that it doesn't work. So it works if you have a v4 existing network. It doesn't accommodate customer allocations. So you probably still, you might use this to replace your /30s or 31s on your routers, but you're probably still, when you have a customer that wants a 48, you give them a real 48. And some older software requires you to manually translate the hex. So Juniper, basically, all known versions that do IPv6 support, you just enter it in mixed form, and it'll actually stay in that form. So you type, your v4 address, and it'll stay that way. And if you have any Junipers on your network and you find yourself wanting to do a quick conversion, you can just ping whatever, and you enter the decimal, and it'll convert it to hex for you on the spot. So I use that as just a handy way to get that. On Cisco, I only talk about 6500, 7600 here because A, that's mostly what's deployed, and B, that's what I had to test with. But any of the newer code there, anything that's been out for the last couple of years, anything in the SR train, anything in SXH or SXI will automatically convert to hex for you. Some of the older code out there, SXF, et cetera, you'll have to do the conversion yourself. And for whatever reason, it doesn't seem to be supported in XR. So, talk about routing protocol support for rolling out v6 in a network. You have two choices, OSPF or is. Don't even think the word rip-ng. Seriously, let it die. OSPF is implemented with an entirely new version of the protocol called OSPF v3. It runs in ship-in-the-night configuration, so you configure your OSPF, you configure your OSPF v3 exactly the same way, but you duplicate all your configurations. Is supports v4 and v6 simultaneously, so you may not have to do any additional work at all if you run an is network. But But you need to make a choice when you do v6 as to whether you want to run in a single or multi-topology config. The advantage in doing a multi-topology config is your v6 doesn't have to match your v4. There may be some router links that don't support it. There may be, what we've seen is there's still software bugs out there where v6 forwarding stops working on one particular interface for some reason, and you may just have to pull it out of the network. So if you run multi-topology, it's a lot easier to just pull v6 on one particular link until you can reload the router or recreate the interface, whatever the case may be. The disadvantage is you have to configure metrics for v4 and v6. So, you know, everywhere you have is metric 10, you now have to go type is IPv6 metric 10. For v6, or I'm sorry, for BGP, pretty much every router out there has a modern BGP implementation that supports multi-protocol. That means you can have a v4 BGP neighbor. The TCP session can be transported over v4, and the route itself can be a v6 address. So you can have one session which carries multiple families. The advantage, obviously, is that it's easier to maintain as a single session. The disadvantage is that you don't have a liveness test. So, like I said, where there's a case where a router breaks v6 forwarding only, you may not know that if your BGP session is over v4, and so you may black hole. Whereas if you do have a separate v6 session, it'll function as a liveness test. So it'll go down, and you'll stop trying to route over it. My personal recommendation is that you do multi-protocol for IBGP and do native for EBGP. And that, you don't have a liveness test for IBGP anyways. So, some configs for Cisco. You need to turn it on, obviously. If you have some platforms where you have to turn on Ceph if you want it to actually forward, any number of packets without falling over. For certain platforms, you have to recarve the TCAM. So for your 3500 type top of rack switches, you have to change your SDM profile. What happens here is it pulls some space that was previously allocated for v4, puts it into v6. The problem is it's not dynamic. So this lowers your TCAM space. So in v4, what your network previously worked before may not work now. A lot of people have run into problems with this, especially because it doesn't just change the number of addresses, it changes the profile of what's directly connected versus what's a route that you learn over a routing protocol. So there's a lot of people out there that run hosting shops that turn this on, that are redistributing all their stuff into their OSPF, and then all of a sudden find that they don't have enough TCAM for their v4. For 6500, 7500 type switches, you have to set some amount of maximum routes for your Ceph. Juniper doesn't really require anything special to get started. It's just there. So, really very simple configuration. All you need to do is add your IPv6 address to your interfaces. So here's an example of where you can type in the v4 address based on what you already have configured, and it converts it to hex for you. Or you can convert it to hex and type it in yourself that way. And this example is assuming that you're doing multi-topology. So you turn on as-is, you do IPv6 router as-is instead of IP router as-is, and you type your IPv6 metric. So it's pretty simple. For Juniper, all you need to do is throw in your family INET6, stick in your address, and it'll stick like that. For Cisco OSPF, all you need to do is make another instance where previously you did router OSPF blah, now you do IPv6 router OSPF blah. The configuration is really pretty much the same, except there's a few knobs that you had under OSPF v2 that you don't have under v3. But I mean, if you've configured OSPF, it's the same thing. For Juniper, it's same story. You just replicate your OSPF over to OSPF v3, and it's the exact same config. For doing as-is on Cisco, you create a new address family. So in this example, I've configured multi-topology. You don't have to do that. You configure a new address family under your existing as-is config, and you replicate some things like what you're redistributing, maximum paths. There's some duplication of configs, but wow. But it's pretty much the same thing. For Juniper, all you have to do is turn on topology IPv6, IPv6 unicast, assuming that's what you're doing, and it's there. It uses all the exact same configs. Very quick and easy to see that your as-is is working. Now you're showing up topology unicast and IPv6 unicast. On Cisco, you type show IPv neighbor detail, and you see that there's now an IPv6 address on there, so you know your as-is is working, carrying v6. OSPF is the same as regular OSPF. For your IBGP configuration, all you have to do is create a new address family. This is a new syntax for people that have used v4 only. Basically, you just go create something in address family v6, and it'll activate the new config, and it'll turn all your configs into, there's now a top portion that just defines the session itself, and then there's address family. So anything in your v4 will now separate part of your neighbor config down into the v4 address family. And you have to go into the address family, do neighbor whatever, activate, and then you apply your specific configurations there. And it's the exact same with v6, except you go into address family IPv6. For Juniper, you turn on family IPv6 unicast. That's really all there is to it. The nice thing about v6 is you really do end up reusing the exact same policy statements. So the network really does operate the same way as it did with v4. You don't have to change anything. You don't have to do anything. You just turn it on. And here's how you verify that it worked. You now have some routes in your INET6 table, and you now have displays for your neighbor. When you show BGP sum, it shows you your INET6. For Cisco, you do show BGP IPv6 unicast summary, and there's your session, and there's your routes, and you see that it works. For doing static routes, all you need to do for Cisco is change IP to IPv6. And also, you don't have to use the long netmask format anymore. Everyone say, yay. At least Cisco finally did something useful. For Juniper, you just stick everything under your routing options. You stick it under rib INET6. Otherwise, it's the exact same configuration, the exact same syntax. You can stick all your regular v4 configs under inet.0 if you want to make it consistent. But it's just, if you don't specify a rib, it's assumed to be inet0. For implementing prefix lists, for Cisco, you can name them the exact same thing as you named your v4 prefix list. So you can have the same prefix list example for IP and IPv6, and it'll apply the correct one based on how it's referenced. So this is really handy for doing, a prefix list for a customer where you do v4 and v6 on the same router. You use the same prefix list name, and it just knows based on what protocol it's applying it to. For Juniper, a little more complex. You have to break it out into separate terms. So this was a recently added feature that you're able to intermix them in the same policy at all. But I went back and tested. The oldest code that I had to test with was 9.1, and it's definitely implemented there. So you just break it out into term IPv4, term IPv6. In some older code, you actually had to have two separate policies. You couldn't intermix a route filter statement at all. But now you can do it with separate terms. So for the most part, you can't go in the same term. Seems too easy, doesn't it? So here's all the fun stuff where this starts to break. Cisco and Juniper have different meanings of next hop self. Well, it's funny because they actually mean the same thing, but they have different ways of implementing it. In Cisco, when you say next hop self and you say update source loopback 0, if it's a v4 route, it'll go find the v4 address in your loopback 0, and if it's a v6 route, it'll go find the v6 address in your loopback 0, and it just works. Juniper next hop self, you're not specifying the interface, you're specifying an address. So say you have a v4 BGP session with local address 1234, and now you have multi-protocol BGP, and you set next hop self. When you hit a v6 route, it's still going to want to use the v4 next hop. The problem being that that's probably not a valid v6 address. So what it does is it turns it into : your v4 address, which is probably not what you want, and that's just a design flaw. So the best way to work around this is just to make that a valid address. So under your loopback 0, under your family INET 6, you go make a secondary, basically, where you put your v4 address in as v4/128. And now this will be a valid address, and anything that you originate from this router and do next hop self on will be valid. Doesn't solve the next hop peer problem.
Right, it'll be valid.
It'll be valid to you. Well, I'm basically, the issue comes up in IBGP. When you have a Juniper router that originates the route, it's going to set its next hop to itself, and so you want it to be valid within your network. When you cross boundaries, obviously, when you do next hop self on a, it's gonna break if you do multi-topology EBGP, which is another reason not to do that, basically, because you're setting next hop self based on your v4 address, and that's not going to be supported.
But this is just to get it all the way inside your network to your network.
Exactly. So you don't have to do next hop self on your EBGP. That's implied. So it turns out there's not a lot of support for IPv6 and MPLS shortcuts, or to quote VJ Gill, to traffic engineer first you need traffic, which is why it hasn't been a problem for v6 so far. But it turns out that iOS doesn't actually have a way to do IPv6 into MPLS as a next hop. And JunoOS didn't add it until 9.3. But as of 9.3, you can now turn on IPv6 shortcuts. So you can put all your IPv6 traffic into MPLS and expect your network to work the way that it would. If you don't, it's just routed natively. It just doesn't go into MPLS. And that may or may not be a problem for your capacity if you're doing traffic engineering, but you probably don't have enough v6 traffic to matter anyways. IPv6 packet filtering. So people that are experienced with IPv4 know that you use ARP to resolve an IP address to a MAC. In v6, you now use ICMP neighbor discovery. So this turns out to be a real kick in the teeth for people who just filter all ICMP and then expect things to work. And this has happened with several of our peers when they go to turn up v6 and find out that neighbor discovery doesn't work. It'll also be a kick in the teeth for people who rate limit ICMP without making an exception for neighbor discovery, who now find out that they get a flood and all of a sudden they stop being able to resolve MAC addresses. And there's also an interesting issue where Cisco actually tries to work around this problem, where when you have an implicit deny in your ACL, it actually inserts silently an implicit accept for ICMP neighbor discovery before that. But people that don't understand that may do some debugging later, and they may insert an explicit deny and all of a sudden find that their ICMP is blocked. Don't want to do that. It turns out there's a bunch of other issues. Older platforms, Juniper Internet Processor 2 architecture doesn't do ECMP or link aggregate hashing on v6 packets. It's just the older ASICs aren't capable of looking at the layer 3 and layer 4 information inside v6 and doing hashing. So when you start passing a lot of traffic, you may find that all of a sudden it's going to end up on one link, and that might be a problem for you. Eventually when you start doing IPv6 traffic, which may not be for quite a while. And also the size of the v6 packet, or the size of the v6 address can consume a lot more routing resources. So for example, on a Cisco SUP 720, you have basically a 144-bit TCAM entry. There just isn't enough space to address the entire 128 bits of the packet, plus the source port and the desk port, plus the TOS, plus all the other things that you can match on. So what happens is, when you use an address that's longer than a /88, it turns off your ability to do layer 4 ACLs for that route. So that's something to consider if you do ACLs on Cisco, which I don't. So in summary, IPv6 is not a perfect protocol. There's still issues that occur. There's plenty of situations where a router will stop forwarding v6 or stop forwarding over an interface, where the only way to solve it is to tear down the interface and rebuild it. So there's going to be bugs. There have been a couple of instances of magic packets where a corrupted v6 packet or an engineered v6 packet will crash the router, but there haven't been a lot of those recently. So we haven't had a problem with seeing those in the wild. as more people start to use it, I don't expect to see that being a big problem. A lot of the currently deployed hardware out there may work now. It's going to have problems when you start getting gigabits of traffic, but we're not there yet. So with any luck, we'll be upgrading our networks for other reasons and work around that problem. You're also not going to see native v6 implementations without v4. There's a lot of routing protocols that are still missing. Like there's no LDP v6 implemented yet anywhere. But all that said, it's really not that difficult to turn on v6. And there's a handful of rules here that I kind of went through and listed out all the major gotchas that I've seen people have problems with. And after you eliminate those, it really is just as simple as configuring a v6 address, turning it on your routing protocol, and there you go. And that's it. Questions?
Sorry to answer it. How can you configure peering over a link local address instead of having global addresses over your previous?
How do you or can you?
Actually, first, can you? And is there a reason not to?
You can. What I'm talking about here is router-to-router configurations. So the reason you want globally unique IP space is so you have DNS, so traceroute works, so people can troubleshoot their network as they've always expected it to. You could use link local if you wanted to keep that isolated, and that's actually a good alternative to using 1918 space that a lot of people do to keep. Well, in v4, people use 1918 space to hide their traceroutes so they can't get a denial of service attack against router IPs, and then that gets blocked by people who are filtering 1918 space, and now your traceroute doesn't work. So using link local, if you really don't want DNS to work, if you really do want it to be isolated, is a good option. What?
Unless you're going to put link local in your IGP or you get next hop.
Obviously, that would apply only if you're doing next hop self off your router. If you're not doing that, you would want to carry your next hop in your IGP, which means you wouldn't want to use link local. Yes.
Hey, Richard. Thank you. You have 30 minutes free. Can you show us real time how to do it? No?
No.
No, okay. I had a question. You mentioned you ran into something with the SUP 720
Yep.
with TCAM space for layer 4 ACLs and 128-bit addresses. Can you explain that in depth?
Basically, it's just a problem of address space. There's a limited amount of hardware resources for a firewall lookup, and you can't do a firewall match to the full 128 bits and specify a layer 4 port at the same time. So if you're using an address that's longer than /88, the router will throw a log and it'll say it's gone into compact mode, and it'll tell you that you can't turn on an ACL that way. I think if you configure it, it just goes to the CPU as a CPU punt, so you don't get hardware filtering. But it'll warn you if you do that.
So that means if you configure an ACL that specifies a target, a source or destination target that's longer than /88.
So what happens is if you configure anything that's longer than a /88. So this is an option. I forgot to mention that, but this is one reason you might not want to use a /96 for your v4 to v6 space, is obviously you're going to exceed that. So you could, pull out a 48 or a 64, whatever the case may be in your network, and use that. There's no reason that you have to be all the way to the end. It just makes for a nicer looking address.
Got it. Thanks.
Even if you had a point-to-point link with a /126 or something and was trying to stop telnet into the router, that would still still qualify as
So it does get filtered, but it gets punted to the CPU. So on the telnet to the router anyways, that's going to happen. But it isn't an issue for me because I do filtering on the Juniper side anyways. But it is a concern if you want to do for full, you want to be able to specify out that long. But you can look up IPv6. It throws an error message when you do it. It's compact mode, something or another. So you can look that up and see all the specific rules. But that's what I saw. Other questions? Yes.
Can you talk about additional ICMP packets for things like MTU? Filtering, and there's more to it than that.
Well, that's pretty much the same as IPv4. If you filter your path MTU discovery, you're going to have a problem. So obviously you don't want to filter all ICMP, but there's people that don't understand that you need to make an explicit allow for neighbor discovery. So if you copy your existing v4 ICMP filters over to v6, you also need to allow neighbor discovery. Things like packet too big, that they changed the name around on a few things, so you'll be poking around the CLI changing the name anyways. But things like packet too big, you still want to allow, otherwise you're going to break path MTU discovery and you're going to piss off some people somewhere that are trying to use jumbo frames. Anything else? I guess not. Oh. I don't know off the top of my head, but I know they raised it. Was it 1,200 something? It used to be 576 minimum packet size for v4. Now it's been raised. Okay. So make sure your network supports that, which for the most part, everyone's network is 1,500 based anyway. So.
I'm finding that if I add VSync during sessions in BGP, Cisco routers have actually an explicit shutdown, no shutdown to get it to come up. I'm wondering if anyone else has been seeing that. It could be a port convert to a version of it.
I haven't seen that. The question was, as he's turned up v6 peers for people, he's had to shut and no shut the peer to get it to come up. I would expect to see some period of time where it's doing the neighbor discovery, but we haven't run into that issue. I mean, for the most part, it's you implement the neighbor the exact same way as you do with v4, except you do address family IPv6 instead of v4, and you use an address that has some colons in it.
Yeah, that was my expectation. I expect this to look like that.
Yep, that's how we've seen it. Anybody else?
You mentioned that Juniper basically screwed doing the
Next off. Yep.
Have they indicated they're going to fix that or stand by the mistake?
I've mentioned it to a bunch of people a bunch of times, and they go, "Man, what are you going to do?" So maybe if you're a bigger customer with some weight to sling around, you might want to complain about that. Apparently not with Juniper. But yeah, no information of any plans to fix that anytime soon. Anybody else? Yes.
Do you have any experience with IPv6 and SLB?
None. As far as I'm concerned, I make the network pass the packets, and what happens after that, IPv6 is still broken enough that that's probably someone else's issue. But you know, at this point, there's a lot of people out there who really do have v6 requirements where they're not going to buy service from you if you don't support v6, even if they don't support v6 yourself. So my answer to the market driver is you need to do that just to make people happy, make people with checklists happy. So there is a market driver, even if they're not doing gigs of v6 and you're not billing for it today. So. Anybody else? No, guess not. Refunds?